The Daheshist Theory of Reincarnation. Part 1. The Multidimensional Universe. In his book, The Forerunner, published in 1920, Khalil Gibran wrote a short parable called Other Seas. A fish said to another fish, "Above the sea of ours, there is another sea with creatures swimming in it. And they live there, even as we live here." The fish replied, pure fancy, when you know that everything that leaves our sea by even an inch and stays out of it dies. What proof have you of other lives in other seas? There are those, including the brightest luminaries of physics, who believe the universe to be arbitrary in nature and not the result of some grand design. With fierce determination, they cling to the notion that there was no time before the Big Bang for any sort of intelligent designer, let alone a divine creator, to exist in. As far as logical conclusions go, I might have agreed with them had I not come in contact with Salim Musa Ashi, also known as Doctor Dahesh, founder of the Dahesh Museum in New York City, prolific author, and most importantly, founder of the Daheshist faith, the birth of which he proclaimed on March 23, 1942. The physical manifestations that occurred when he was present were nothing short of miracles to many of those who came in contact with him, including Mrs. Marie Haddad, noted Lebanese scholar and painter. News and urban legends about him spread like wildfire to such an extent that the government of Lebanon, incited by the clergy and led by President Bashar al-Khoury, brother-in-law to Marie Haddad, would enact an elaborate scheme to eliminate him by the end of 1944. That scheme included buying off the newspapers, assassination attempts, incarceration without due process of law, the illegal removal of his citizenship, torture and exile to Aleppo, then Azaz, Syria. It would all culminate in his being abandoned on a deserted road, under cover of darkness, without food, money, or identification papers, in Turkish territory as World War II was still raging on. The following presentation is not about how Dr. Dahesh would claw his way back to Beirut from certain doom and hide in the Hanani Palace, which is located right across from the presidential palace, home of his sworn enemy. However, and for the record, from inside the Hanani Palace, Dr. Dahesh would launch an underground magazine called The Black Books. There were, in total, 66 black books, whose publication ran from 1945 until 1952. Mrs. Marie Haddad would bravely put her name to every issue as the author. In them, using words and photographs, Dr. Dahesh would systematically expose the corrupt president and his wife, Laura Khoury, sister of Marie and chief architect behind the campaign to eradicate Dr. Dahesh, ultimately fueling public outcry and massive demonstrations that forced the president to resign on September 18, 1952. President Camille Chamoun would subsequently restore Dr. Dahesh's citizenship, but as I said, that story is for another day. This is about a much bigger picture that involves all of us on this planet and why we are here. Therefore, please think of the following as being as much a testimonial on behalf of theoretical physics as it is a testimony to the role Dr. Dahesh played in showing me tangible proof of the divine power's existence. Given the fantastic nature of the events I have witnessed, and some of their implications I was privy to, it is both my privilege and duty to act as your guide through a road perhaps not taken, one that has personally provided me an impetus to embark on a lifelong quest for knowledge about the wondrous nature that is our existence. Anything less, and I will have disavowed all I have seen and believed and forfeited my soul. And I am fully aware of the reality that there is no tangible, physical proof that God exists, at least not the kind that would satisfy a mind trained to follow the scientific method, notwithstanding some of its limitations, which is a complex process that can take many directions and starting points. On that front, because the scientific method requires completely controlled experiments to test a hypothesis, any hypothesis, science cannot prove everything. That is why, for example, claims about God and the world of the spirits can never be confirmed or falsified, given that no experiment currently exists that could test their presence. And given that I personally do not believe in, nor wish to promote, pseudoscience, I will not attempt to misrepresent my beliefs as being scientific. Whether I like it or not, there is a line in the sand. Somehow, countless witnesses, including me, have found themselves in a position that is a proverbial no man's land between science and faith. For the record, I understand that the scientific method is a road meant to lead us to a better understanding of the mysteries of the natural world by refuting previous hypotheses. Thus, any discussion about the existence of supernatural beings automatically lies outside the realm of science altogether. Another limitation, or perhaps virtue wired into the scientific method, is that it is strictly objective. Science alone cannot tell us whether certain natural phenomena are good or bad for the world, as it can only address and study the objective causes and consequences. Lastly, science cannot tell us what is moral or otherwise because scientific results lie outside the scope of cultural, religious, and social influences. Be that as it may, and for the sake of clarity, I will borrow some terms from science, such as frequency, wave, and particle, in order to better construct a picture of the universe according to the Daheshist faith. And speaking of faith, or rather mathematical faith, there are many noted and celebrated theoretical physicists who believe our cosmos did not randomly spring out of nothingness. On the contrary, they present strong mathematical evidence that our universe might have been born from the splitting or union of other universes, much like soap bubbles behave. When two soap bubbles collide, they can form one whole soap bubble. Conversely, one whole soap bubble can split into two perfectly whole soap bubbles. In a February 9, 2003 article called Theories of the Brain, and by the way, that's brain, B-R-A-N-E, as in membrane, Harvard physics professor and acclaimed author Lisa Randall writes, quote, "Additional spatial dimensions may seem like a wild and crazy idea at first, but there are powerful reasons to believe that there really are extra dimensions of space," end quote. Then she cites string theory, in which it is postulated that what we think of as fundamental particles are oscillation modes or expressions, if you will, of something called a fundamental string. And we will be looking more at that a little later. As to why we should trust mathematics in the first place, first and foremost, without mathematics, namely calculus, physics, starting with classical Newtonian physics, which is still used today, for example, from designing and erecting skyscrapers to shooting a rocket into outer space and landing a probe on planet Mars, would not exist. Physics uses mathematical equations to elegantly, and sometimes not so elegantly, describe the way the four fundamental forces that govern all matter in the universe behave. Those forces being gravity, electromagnetism, the weak and the strong nuclear forces. Gravity, which keeps our feet firmly rooted on the ground, is what happens when objects that have mass bend and distort space and time. Electromagnetism, which is responsible for the electrical and magnetic fields, gives us light. The weak nuclear force acts on the subatomic level and plays a crucial role in powering stars and creating elements. It is also responsible for much of the natural radiation present in the universe. Last but not least, the strong nuclear force is responsible for binding together the fundamental particles of matter to form larger particles. With this short review of the four fundamental forces that govern our universe out of the way, I will tell you a little story illustrating the importance of mathematics. On July 24, 2014, 2 years after CERN announced the discovery of what was thought to be the Higgs boson particle, the scientists at the Large Hadron Collider confirmed that they had indeed detected the Higgs boson particle and that it behaved according to the standard model of particle physics. Now, why is the discovery of this particle significant? Better yet, why should the discovery of any new particle be exciting to science, especially that physicists had always been complaining of having too many particles to deal with? As a matter of fact, every time scientists smashed particles into each other, they got more particles. And when, in turn, they smashed those new particles, they got even more particles. As early as the 1950s, physicists were inundated with particles. It got so bad that J. Robert Oppenheimer, the father of the atomic bomb, once declared that the Nobel Prize in Physics could go to the physicist who did not discover a new particle that year. Still, they were able to fit all these particles together in a sort of a jigsaw puzzle they call the standard model of subatomic particles. There was one missing piece, though, called the Higgs boson, a particle that gives mass to all the other particles. But what is mass in the first place? Noted string physicist Brian Greene, in a World Science Festival video segment, explained that when we push on a wall or any object, we feel resistance. Logic says it is due to the constituents of the object. That is the mass. So a piece of concrete has mass because cement, sand, and gravel each have mass. But what gives mass to the constituents of the constituents themselves? What is the thing that gives mass to everything? To answer that question, physicists paint the image of space itself filled with an invisible substance called the Higgs field. Particles, such as electrons, attempting to move through space, interact with this field and become imbued with mass. How were they able to confirm this hypothesis through experiment? Brian Greene explained that they did so by taking particles and slamming them at near the speed of light over and over until finally the Higgs field reacted and flicked off a tiny speck of itself, in essence the Higgs boson particle. It took hundreds of trillions of collisions for the Higgs field to flick off a Higgs particle. Therefore, it is very hard indeed to find one. Furthermore, the Higgs boson, which is unlike any particle found to date, arguably an alien species of particles given that it does not spin around, brings us one step closer to solving one of the fundamental questions in physics, which is, where did the elementary particles get their mass from? Lastly, and as regards the importance of mathematics, the Higgs boson began as a mathematical formula in a paper. Purportedly, 40 years of technological development, billions of dollars, and 20 Nobel Prizes had already gone into the creation of the standard model, and unlike the otherwise beautiful equations of Einstein's general relativity, it is not a pretty theory as far as physicists are concerned, but, according to them, it works. The Higgs boson shows us that even in the vacuum of space, the lowest state of energy in which there are no particles around, there might be a background field of some sort which permeates the universe. This background field can be, for lack of a better action verb, whacked in such a way as to give rise to the Higgs boson, which will ultimately help us gain understanding about two mysterious entities, one called dark matter and the other dark energy. Dark energy makes up 73% of our universe.
Michio Kaku,
a leading theoretical physicist credited with co-founding the string field theory, calls it, quote, the energy of nothing, end quote. As he puts it, dark energy is what's blowing the galaxies farther and farther apart. He describes it as, quote, the energy of the Big Bang itself, end quote. Dark matter, on the other hand, which is invisible matter, makes up 23% of the universe, and it is pretty mind-boggling in the sense that, although you can certainly call it matter, you would not be able to hold it in the palm of your hand. Aside from being invisible matter, hence the name dark matter, it would go right through it. Yet, it is what holds our galaxy together. More than that, it holds other galaxies as well as other galaxy clusters together. But why does any galaxy, or galaxy cluster for that matter, need any special cosmic glue, as it were? After all, the velocity of stars orbiting the central mass of a galaxy depends on how far they are positioned away from that central mass. That's classical Newtonian physics. The closer the stars are to the central or inner mass, the faster they should orbit. Conversely, the farther they are, the slower their orbiting velocity should be. Otherwise, they would fly out of orbit. So for all intents and purposes, as long as the laws of physics are respected and barring any cataclysmic event, why even bring it up? Well, in the 1930s, astronomer Fritz Zwicky, who coined the term dark matter, detected a paradox. So did Vera Rubin, who in the 1970s was studying the rotational curves of galaxies that are similar to our own Milky Way. By analyzing a large number of different galaxies, Vera Rubin produced measurements showing, strangely enough, that as we got farther and farther away from the center of a galaxy, the velocity of the orbiting gas and dust remained constant. In other words, she unexpectedly discovered that the stars rotating around the galactic center did not, as it were, adjust their speed in order to remain in orbit around that galactic center. What Rubin observed, therefore, was that the outer parts of a galaxy were rotating at speeds that suggested the presence of more mass than was actually visible. And the only way to resolve that paradox of galaxies, whose outer parts spin 10 times too fast, is to imagine and accept the presence of a halo of invisible matter that surrounds a galaxy and keeps it whole. Rubin found that there must be 5 or 6 times as much invisible material as there is visible material in galaxies. While we certainly cannot directly see dark matter, it can be detected through gravitational lensing by observing how its mass affects the path of light coming from distant galaxies as it makes its way through this dark matter that envelops galaxy clusters. Moreover, it does interact with normal matter through gravity by affecting how galaxies rotate and form clusters. And here, we realize the importance of dark matter. You see, the prevailing thought as regards how the universe was formed goes as follows. First, stars were formed, then galaxies, then the galaxy clusters. Great, except that there is an inherent problem or paradox within this model, being that stars are, technically speaking, violent, explosive fusion reactors blasting out energy with such force that any notion of them merrily clumping together to form galaxies, let alone clusters, is not only counterintuitive but unthinkable. The inclusion of dark matter in the physics, however, makes all that possible. And it should, considering that the stars, which are essentially hydrogen and helium, make up only 4% of the universe. And what about us, human beings? Where do we fit in? For starters, 98.5% of a human body, as well as that of most living organisms, is composed of 6 elements, which are oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. The remaining 1.5% consists of very small amounts of trace elements. In all, we make up 0.03% of the universe. Speaking to future generations of physicists,
Michio Kaku said,
quote, "We are the exception. The universe is mainly made out of dark energy. The universe is mainly made out of dark matter, overwhelming the stars, overwhelming the galaxies, in fact. And we only make up 0.03% of the universe. The future of physics is you." End quote. Still, dark energy, dark matter, it all sounds like science fiction, doesn't it? And that brings us back to the whole issue of God and the controversial notion that our universe was fine-tuned for life and mind, an idea that has generated much energy and controversy among scientists, philosophers, and theologians. During an on-camera conversation with Robert Lawrence Kuhn, Leonard Susskind, one of the fathers of string theory, best known for having proven Stephen Hawking wrong with regard to what happens when something falls into a black hole, suggested that it does look as though the laws of physics, of cosmology, and how the universe evolved seem to be special in a way that is unexpected. Special in a way that is, quote, very, very conducive to our own existence, end quote. On that episode of Closer to Truth, Leonard Susskind invites us to imagine a world without electrons. We learn that if electrons did not exist, there would be no atoms, no chemistry, no biology, or people for that matter. In short, life as we know it. What about gravity? While from our everyday human perspective it does appear as if gravity were strong, compared to the other forces in nature, it is not. In fact, if you were to compare the gravitational force between the electrons and the protons inside an atom, it is negligible compared to the electrical force. While it is not known why gravity is so much weaker than the other forces, one thing for sure is this. If gravity had been even a tiny bit stronger than it currently is, stars, such as our own sun, would burn out too quickly for any life to evolve. Instead of stars and galaxies, space would be littered with black holes, and the universe would expand and contract too rapidly. As Professor Susskind put it, quote, "Everything seems to be almost on a knife edge. That if you were to change the rules of physics, the laws of physics, even a little bit, the world as we know it wouldn't exist." End quote. There is a debate about how many laws or constants of physics there are that fit into this category of fine-tuning or description of being on a knife edge. As it stands, the universe would not look as it does today if a couple of dozen constants of nature were to undergo some degree of alteration that extends beyond a few percent. Therefore, it is safe to infer that the state of our universe and the fact we exist is the result of a highly precise recipe, a balancing act, if you will, between all the various constants of nature. There is one constant, however, called the cosmological constant that is unlike any other. Professor Susskind describes it as the one that is really on a knife edge. He describes it as being on such a narrow knife edge that it is almost inconceivable. In other words, if we were to change the cosmological constant the tiniest bit, none of us would be here. Remember that thing I briefly mentioned earlier called dark energy, which is blowing galaxies farther and farther away? Well, dark energy can be thought of as a sort of an anti-gravity. Where gravity brings things together, anti-gravity is repulsive and causes them to move away from one another. It is implicit in Albert Einstein's equations for general relativity. That energy could be there. Physicists, according to Susskind, have every theoretical, not experimental reason to think the world should have this kind of anti-gravity, which would cause everything to separate at an enormous rate. Historically speaking, in 1917, as Albert Einstein was analyzing his equations for general relativity, he found that his mathematics was wrong, or so he thought. According to his math, he found that the universe could either be expanding or contracting. Given that Einstein and the rest of the world at the time believed the universe was eternal, unchanging, he came to the erroneous conclusion that his equations were incompatible with the idea of a static universe. So, in order to rectify the situation, he introduced the cosmological constant, denoted by the Greek capital letter lambda, into his theory of general relativity to artificially force a static universe. But when, in 1929, Edwin Hubble discovered the universe was expanding, Einstein abandoned lambda, calling it his biggest blunder. Now, there's nothing particularly impressive in the concept of an expanding universe which began with an explosion of epic proportions known as the Big Bang. Please humor me. Everyday logic dictates that all the stuff that was projected out of that initial bang, just like shrapnel 15 billion years ago, would be decelerating due to gravity. In fact, there is a theory called the Big Crunch that is one of the scenarios predicted by scientists in which the universe may end. Also based on Einstein's theory of general relativity, the Big Crunch describes how the universe will end as a result of the Big Bang. In a nutshell, the universe will stop expanding and collapse onto itself, creating the mother of all black holes ever. Simply stated, the idea that the gravitational forces will end up winning in the end seemed like the only logical conclusion. When we throw something up in the air, it will eventually come back down as long as no other force keeps pushing it up. This makes perfect sense. Or does it? In 1998, scientists discovered that the universe was actually increasing its rate of expansion at regions farthest from us. Hence, the expansion was accelerating. To explain that unexpected phenomenon, they assumed the presence of some unknown entity dubbed dark energy. This cosmological constant that is pushing all galaxies farther apart by, quite literally, creating space. And under the current scientific model, where dark energy is a cosmological constant, the universe will keep on expanding exponentially with time, with all evidence of the Big Bang disappearing.
In fact, and in 100 billion years, future scientists, if there are any to be found, will derive a picture of the observable universe as being one galaxy surrounded by empty space. That is, a universe that is static and eternal. Eventually, and according to the heat death of the universe hypothesis, also known as the Big Chill or the Big Freeze,
the universe will turn utterly dark. Now here's the really mind-boggling part. The actual magnitude of this cosmological constant is so incredibly small, so tiny, that its effects are only felt on the largest possible scales of the universe. In other words, it takes a gigantically large expanse of space and time for the cosmological constant to create any repulsion. And with regard to mathematics, it is not because the equations tell us it has to be so. There is no mathematically logical reason things are this way. Instead, and according to Professor Susskind, it is because, quote, whatever made the universe made it with an incredibly small, tiny cosmological constant, and no one knows why, end quote. One thing we do know is the following. Had the cosmological constant been a little bit stronger, it would have blasted galaxies apart, it would have prevented stars from forming, all of which formed because gravity pulled them together in the very early universe. Therefore, any sort of premature counteracting anti-gravity would have surely prevented the formation of the stars, planets, galaxies, and our existence. So like it or not, this is a prime example of fine-tuning. Physicists have no way to determine why the cosmological constant is so small. Susskind offers 3 possible solutions. 1, and I believe he said that in jest, that God did it. 2, it happened totally by accident, that it is a pure accident it turned out just that way and that it works perfectly. However, given that we are dealing with 123 decimal places then 0, he said, and I quote, "not likely to be an accident." The third and last solution is one which, according to him, physicists do not like because it, quote, "runs against their ambitions," end quote. That is, the ambition to explain every number, every constant, in short, everything about the universe. So that third solution assumes that the universe is far, far bigger than we can see, that it is diverse, that in different places it has different properties. Hence, in some places there are no electrons. In other places, gravity is stronger, and in others, this cosmological constant may in fact be bigger. As it stands, Susskind said, quote, "The picture is that there is a very small fraction of the universe where the conditions just happen to be right for the existence of life." End quote. He explained that the very early rapid expansion of the universe created a lot of quantum fluctuation, which in turn created patches of space possessing different properties. Those patches of space are sometimes called pocket universes or bubble universes. We happen to live in one of them. According to Susskind, that's the picture. There is mathematics that goes with it. He and others believe in this particular picture of a tremendously diverse universe, often called a multiverse. Yet, no physicist, not even one who has accepted the universe is fine-tuned, has concluded that behind all of this fine-tuning, there exists a fine-tuner. As I have mentioned before, and as far as logical conclusions go, that one is expected. After all, even the biggest machine of science ever created, the Large Hadron Collider, has yet to detect evidence of the world of the spirits, let alone that of an almighty God. Parallel to that, and nearly a century after Khalil Gibran's inspired words, some of today's greatest scientific minds believe in the existence of something they refer to as hyperspace. To describe what hyperspace is, Michio Kaku employs the simple analogy of a fish pond where we are the fish swimming about in our three-dimensional aquatic space, unaware of hyperspace that lies beyond the water lilies, a dimension governed by different laws of physics and biology. Interestingly enough, the scientists who might have once been considered to be lunatics, or at the very least very strange, are championing the theory you've already heard me mention, named string theory, which has evolved over the years and which shows that beyond the 3 dimensions we're familiar with, sideways, up, and across, and the dimension of time, the universe may comprise 9, 10, even 11 dimensions. They believe these extra dimensions are there, even though they have not yet been detected. Not surprising, considering the stipulation they reside outside our 3-dimensional universe. Therefore, it would be fair to say that string theory offers a radical way of viewing our universe because it describes the entire universe, including space, time, and even gravity, as consisting of tiny string-like objects or rubber bands that supposedly only appear to us as different particles because of the different ways they oscillate or vibrate. Therefore, string theory suggests that our world is a vibrating mesh of strings. And the reason string theory is relevant is because it brings together two conflicting theories, the theory of relativity and quantum theory. String theory, along with supersymmetry and M theory, provides a framework for developing a unified theory of all of the fundamental forces of nature, the theory of everything, one that Albert Einstein tried to solve during the last 30 years of his life. Leading up to that, he had successfully unified time and space, energy and matter. Even more than that, Einstein fused the idea of space with that of time in such a way that we now accept the idea of a four-dimensional structure called spacetime. And the most mind-bending implication of all is that the contrast between the past, the present, and the future may well be the greatest illusion of all our universe has ever concocted. And if you believe the laws of physics, the past has not vanished, and the future is anything but non-existent. In any case, that is a small example of the beauty that is Einstein's theory of relativity. Still, he could not merge relativity with quantum theory, which he thought was at best incomplete, and he even rejected some of its aspects. Therefore, this elusive theory of everything will have been one that reconciles the theory of relativity, the theory of the very large, and quantum theory, the theory of the very small. And so, with string theory and M theory, scientists now feel they have solved the equation. Except that they would still need to prove the existence of hyperspace, which is an important component in solving the puzzle, and which, among others, would mean that time travel is possible and not just the stuff of science fiction. And who knows, we might solve life's ultimate mystery. Why are we here, and where did we come from? On that front, physicists postulate that the universe, and that includes time and space and all the forces that govern it, started from a single point smaller than an electron. They believe that a thing called supersymmetry, a super force that would have governed our universe when it was still as tiny as a dot, suddenly and inexplicably cracked and unleashed the galaxies, stars, and planets along with time and space. In essence, before the Big Bang, the universe was a perfect whole. Then, for some reason, maybe due to the collision of universes predicted in M theory, unraveled and became other than the sum of its parts. Thus, a side effect of this cataclysmic event is materialization in of itself and the formation of space-time along with the four forces governing the universe: electromagnetism, gravity, the strong force, and the weak force. Another mind-bending notion that physicists and cosmologists are now open to consider as being possible is the notion that the universe is a kind of a hologram. Simply put, a holographic image, something we have all seen on credit cards, gives the illusion of a three-dimensional object by way of casting a sculptural impression inside a thin sheet of high-resolution film. Although to the naked eye, that thin sheet of high-resolution film is two-dimensional, it nevertheless has a thickness of 10 microns. Therefore, it is within that 10-micron depth that a sculptural impression of the pattern of information from light waves is cast. And so, through interfering light waves furnished by lasers, an imprint is created, physically speaking, within the depth of the sheet of film, which is, for all intents and purposes, a flat two-dimensional surface. And that is why we can say the holographic illusion of a three-dimensional shape is stored as information on a two-dimensional surface. In any case, today, scientists are open to the idea that everything is a kind of a hologram and that everything we see and experience or deem to be a familiar reality may in fact be nothing more than a projection of information that is stored on a relatively thin and distant two-dimensional surface. Now, where did this otherwise crazy idea and potentially most drastic proposed revision to the notion of reality come from? Black holes. It turns out that modern ideas emanating from the study of black holes, those formidable regions of space so dense that nothing can escape from them, not even light itself, point to a reality that is two-dimensional in nature, and that the three-dimensional world is a kind of an image of a hologram plastered, if you will, on the boundary of space. Originally, Stephen Hawking, representing the principles of general relativity, made the claim that any material that fell into a black hole would disappear forever. Hence, the prevailing thought was that anything thrown into a black hole would be lost forever, unable to be retrieved or reconstituted. And that notion, from an everyday logical perspective, is the one most people would be comfortable with. However, Leonard Susskind, representing the principles of quantum mechanics, among which is arguably the deepest principle in physics, which says information is never lost, did not agree. And that is how the infamous Black Hole War began in 1981, which lasted for decades and culminated in Susskind's 2008 book titled Black Hole War: My Battle with Stephen Hawking to Make the World Safe for Quantum Mechanics. In the end, Susskind managed to prove that the information sucked into a black hole is indeed conserved. That debate led to the holographic principle originally proposed by Gerard 't Hooft and refined by Susskind. By exploring the mathematics describing black holes, an unexpected and curious discovery was made. According to the calculations, even if the object were to disappear into a black hole, a duplicate copy of all the information it contains seems spread out and embedded on the surface of the black hole, the same way information is stored in a computer on a flat disk. Therefore, and based on the math, everything has a three-dimensional version and a two-dimensional version that persists as information. Furthermore, and in theory at least, we could use this information to reconstruct it. And if that were not enough, we end up with a real mind-boggling revelation that space within a black hole follows the same rules of physics that exist outside the black hole or anywhere else for that matter. Therefore, if an object inside a black hole can be described and reconstituted by way of information that is stored on the surface of that same black hole, then it might be that everything in the universe, from galaxies, stars, even space itself, is nothing more than a projection of information stored on a distant surface that surrounds us. In other words, what we experience as reality may be something like a hologram. And therefore, the three-dimensional aspect of reality is an illusion, and the ultimate precise reality is whatever exists on this distant two-dimensional surface of the universe. A mind-boggling concept indeed, and yet none of that, if you ask the rational scientist, has anything to do with suggesting the presence of a creator. As it stands, the scientists are of the opinion that the universe began from nothing and has not existed forever, that it arose spontaneously, and that it will go on expanding forever without the benefit of a creator. Arguably, talking about miracles or divine intervention has no place in this debate because, although no one has yet traveled near or faster than the speed of light, or better still, back in time, there is the hope that one day we might unlock and harness the many mysteries that remain hidden from us. In other words, what may seem like a miracle today may one day feel commonplace. Furthermore, unless it can be detected, observed, quantified, and replicated, or can fit a particular mathematical framework, it is not admissible as evidence, hence irrelevant. Still, I cannot deny what I saw, even though I know there are no current scientific tools or way to process what I have experienced into a theory of sorts, one that Einstein himself might reject as quote-unquote spooky action from a distance, the exact words he used when refuting the idea of quantum entanglement, that indivisible nature of the quantum world in which two particles would communicate instantaneously regardless of the distance between them, thus requiring speeds higher than the speed of light, something that would be proven true through a series of experiments conducted by Alain Aspect and his colleagues in 1982. Also in 1982, a 72-year-old Doctor Dahesh, who by then had suffered a series of painful and often debilitating injuries, was getting ready to leave my New York City apartment located on the corner of 34th Street and 2nd Avenue. I was slated to drive him to his dental appointment in Queens, and as is customary, I had spoken to one of our building parking garage attendants in order for him to get my car ready. Dr. Dahesh and I were in the bedroom, which had large sliding windows overlooking 34th Street with a stunning view of the New York City skyline. The Chrysler Building was glistening a few blocks up north. I remember it being a sunny, crisp autumn day, and time seemed to stand still. Dr. Dahesh had just finished shaving, and I was helping him get ready. You see, his chronic pain had severely limited his movement. As a result, he often required assistance in order to perform certain mundane tasks, such as getting in and out of bed, walking, getting dressed, or putting his socks and shoes on. But being who he was, he tried to be as self-reliant as possible. Therefore, and as far as putting his pants on, he had perfected a technique whereby, with one hand, he would use the desk as support while lowering the pair of pants down to the floor as low as his back could allow him to arch forward. Then, ever so carefully, he would hoist one knee and maneuver his foot into one of the pant legs, then proceed to lift it up to about upper thigh level, pause for a moment, then repeat the procedure with the other leg. Once securely around his waist, he would button his fly and buckle his belt. On average, the procedure took at least a couple of minutes, and I would stand guard ready to jump in whenever needed. In any case, you could imagine how long it would take him to put a pair of pants on. Well, not that long apparently. You see, on that fateful day in 1982, something amazing took place. Dr. Dahesh went from quite literally holding the pair of pants I had just handed him to buckling his belt in a flash, and all I did was blink. Here's what happened in more detail. I handed him his pants, he took them from me and stood there, getting ready for the delicate operation. I walked a few paces to the other side of the room while still eyeing him, and his stance had not changed. I turned my head a fraction of a second towards the dresser, mainly because I didn't want to bump into it, then back to a Dr. Dahesh who not only had his pants on, but was buckling his belt and trying very hard not to grin or look like the cat who just ate the canary. Did I and the whole of Manhattan freeze while Dr. Dahesh put his pants on? Therefore, in looking back on this amazing experience, I believe I witnessed evidence of hyperspace and of time travel, or something in between. As I said, I do not wish to engage in pseudoscience, but this is what I witnessed, and I have no other way to describe it. On another occasion, and this time I had been visiting him at his Greenwich, Connecticut residence, he instructed me to write and burn a Daheshist spiritual symbol, which is our Daheshist prayer, written on a small yellow sheet of paper that is folded, then burned. I did as he asked. I drew the familiar Daheshist star with all the necessary inscriptions, and I added a personal request in the footer, folded the prayer, burned it, and recited the incantation, requesting that our Creator grant me spiritual assistance. No sooner had I placed the ashes in my hand in order to disperse them in the garden than Dr. Dahesh rushed towards me in an attempt to stop me. "What's wrong?" I asked. "You forgot to sign the prayer," he replied. "Are you sure?" I asked in total disbelief. What occurred next would, in my opinion, provide tangible proof that nothing is destroyed, anything can be reconstituted, and that reincarnation is real. Dr. Dahesh uttered the following words: "By God's right and that of the beloved guiding prophet, let Mario's symbol reappear," and gently yet briskly tapped my clenched fist, which, as far as I knew, contained the ashes of the prayer I had just burned. I opened my hand, and right there in my palm, the ashes had disappeared, and in their place, a neatly folded sheet of yellow paper which looked like it had writing on it. Dr. Dahesh instructed me to unfold the paper that had just appeared in my hand, replacing the ashes I was about to throw into the breeze. I simply couldn't believe it. The intricate prayer I had written with my personal thoughts and wishes reappeared after I had just lit a match and burned it down to ashes. And, lo and behold, he was right. I did in fact forget to sign my name, and so I rectified the situation and burned the prayer again, this time in its completed form, and spread the ashes in the garden as planned. For what it's worth, Niels Bohr, one of the fathers of quantum mechanics, and with regard to the unbelievable manifestations of the subatomic world, encouraged us to look, among other things, to early thinkers like the Buddha and Lao Tzu, who sought to harmonize our position as spectators and actors in the great drama of existence. In a February 27, 2014 article published by The Telegraph, Leonard Susskind, who purportedly has no belief in a higher being of any sort, said, quote, "If you ask me, is it possible that the world was created by an intelligent being? I would ask, is that intelligent being made of atoms? Does it satisfy quantum mechanics? And I realize it doesn't help at all," end quote. True, if one believes in an anthropomorphic higher power. But what if such things as consciousness and intelligence, just like the force of gravity, extend from other dimensions, thus spilling or rather vibrating into our own dimension? And on that last note, we come to the end of the Daheshist Theory of Reincarnation, Part 1, The Multidimensional Universe. For a transcript, please visit drdahesh.com. That's DoctorDahesh.com. You may also visit Dahesh.org or Dahesh.tv. This is Mario Henry Shakur saying goodbye until next time.